Hey, what's up, class? Welcome back. Another episode of Math 1 Distance Learning. Hopefully, you guys are doing well. We've been at this for a while. Okay, today I'm going to go over the answers, the questions and answers in your Unit 3 Practice 1 test. So the test is covering functions and slope. So you should have that test in front of you, and you're going to now copy down the correct answers. Even if you did it correctly and you got the correct answer, I still want to see you copy it down the way I demonstrate. So you should have that test in front of you, and here we go. All right, so we are looking at the Unit 3 Practice 1, or practice test number 1. I'm not sure if I'm going to give you a practice test number 2, but this is Unit 3 practice test on functions and slope. Okay, so your original directions, you were supposed to show your work and answers for each problem on the left side over here. And I said, do not write on the right side. We will use that space for corrections. So that's what we're going to do. So now you are showing your work on the right side. So now you're using the right side and you're going to copy down what I explain. Okay, so the original question on number 1 was to determine the domain and range of the graph. So if you notice on the original graph, there are no arrows. We have stop signs. The graph stops, right? It just comes to a stop right there, and it comes to a stop. So I have explained to you previously that this is like when we're figuring out the domain is our x-axis, and when we're figuring out the domain, we want to treat this, if this is our line right here, we want to turn the magnet on for the x-axis. So if I turn this x-axis right here, if that was a really strong magnet, and I turn that magnet on, and all of a sudden this would just go just like that, and this would get pulled up to there, and this one would get pulled down, and everything in between would get pulled down. This would get pulled down, and this one would get pulled down. This one would get pulled down, and that would stay right there, and this one would get pulled up, and this would get pulled up, and now it would get pulled up, and this one would get pulled up, and this would go, and everything would get pulled up until it was right between there and there. So we have a stop sign right there and a stop sign right there. So that would be, we would write that just like this. So we would have stop signs at -1, right? If this got pulled up to here, this would be at -1. And if this got pulled down, that would be at 4. And the other way that you could write it, you may see it on your test like this. We want everything in between from here to here. All of these x values, right? If this was a magnet and it pulled everything up. Okay, now for your y-axis, if this was, let's put this back, and if this is a magnet, if your y-axis, if we turned on your y-axis right here, we turned on that magnet, then all of a sudden this would go, it would straighten up right along there, and this would get pulled over, this would get pulled to here, and this one would get pulled over, and this would get pulled over, and this one would get pulled to here, and this one would get pulled to here, this would get pulled, and this would get pulled, this one would get pulled, and we get this one pulled, and this one would pull over, and this one would pull over, and this one would pull over, this one, and this one. We'd have a stop sign right there. We'd have a stop sign right there. So we would go from -3 all the way up to +2. So your results would be from -3 up to +2, but they would stop, right? So we're going to use those brackets, or it'd be everything in between -3 all the way to +2. So it'd be from here all the way up to here, okay? And if you notice, it kind of makes like a little box almost, right? Kind of makes like a box. So like a boundary, right? Like nothing from here, nothing outside of this, and nothing outside of that, and nothing outside of this, and nothing outside of that. Okay? All right, so that's number 1. All right, on number 2, let's go take a look at number 2. It says an apartment in Fresno, California rents for $600 per month with a $1,000 deposit. The rental is month to month, but you must stay at least 1 month. And then here's a function right here, gives the cost of renting for X months. And the question says, what is the cost to rent the apartment for 7 months? Use the function to answer the question, show your work. Okay, all right, so here's our function right here. Okay, and our X is our input variable, and we want to input the number of months. We want to input the number of months right here for 7 months. Okay, so we want to input that. And so I'm going to go ahead and just plug 7, right? It tells us X is the number of months right here. So I want to plug in 7 right there. So I'm going to do 600 times 7, and that's going to come to 4,200, right? 6 times 7 is 42, and then put the 2 zeros on the end. 4,200 plus 1,000, right? $1,000 deposit. You've got to pay that, and so that's going to come to 5,200. So since it's a word problem, we want to write our final answer in a sentence. So we would say the apartment will cost $5,200 for 7 months. $5,200 for 7 months. Okay, and we just took the 7, we plugged it in for the X. That was our input. Okay, all right, let's move on. Okay, number 3 says express the relation. So here's our relation, right? These are like dance pairs, like dance partners, right? 2's dancing with 3, 2's dancing with 4, and 5's dancing with 9. Okay, so this is like a court of honor, right? Or you're at the prom. We want to change it, put it into a mapping diagram. So my first bubble, down here. So my first bubble is going to have the X values. So I have a 2, there's 2 again, and then a 5. So I only need to put him once, and then I put the 5, and then I'm going to draw arrows to who they're dancing with, and I want to put those from smallest to biggest. So it would look like this. Okay, so 3, 4, 9, right? I went 2 small to big, and then small to big, and now I'm drawing the arrows. 2's dancing with 3, 2's dancing with 4, and 5's dancing with 9. Now, it doesn't ask whether this is a function or not, but we would know that this is not a function because this X value is paired up with more than one Y value. You can't do that. This guy is a 2-timer, right? We can't have 2 timers and be functions. So no 2 timers, okay? All right, let's go to the next question. Number 4 says, tell whether the relation is a function. So we need to explain. So if I look at this, I see, okay, so that's a -4, and then I've got a -3 and a -2 and a -1. So I don't see any X values that are repeating themselves. He's only dancing there, he's only dancing there, he's dancing there, and he's dancing there. So you could write it out like this. So I wrote out the domain. So I wrote out -4, a -3, a -2, and a -1. Then I wrote out my range, and we would say, yes, this is a function. The relation is a function because each X value is paired with only one Y value, right? Each X value, he's only dancing with one person, he's only dancing with one, he's dancing with one, and he's dancing with one, right? So each X value is paired with only one Y value. All right, number 5. Number 5, give the range of the relation. Well, we know that the range is your y value. So when you write the range, we don't have to write repeats. So there's a 2, a 2, a 5, and a 6. So we don't have to, that's the same value. So all we have to do is write a 2, a comma, a 5, a comma, and a 6. And you put, if you want to be really fancy about it, you put these little braces around it and call that the range. Okay, that's your y value. All right, number 6. Identify the independent and dependent variables. So it says a photo lab charges 15 cents, right? That's 0.15, 15 cents per print. Okay, so remember your independent is your input. Independent's your input. Well, which one is the input? We practice this a lot. Do you guys remember? It's always the word that comes after per. It's the word that comes after per. So prints. So our input is our independent. And so remember, it's always the word that comes after per. That's our input. So our independent is the number of prints. And then once we know the number of prints, then we can figure out the total cost. Total cost depends on that. We need to know how many prints we're getting before we can know the total cost. So this comes first, right? Per print. That's your input, which is your independent. Okay. All right, let's move on to number 7. Okay, on number 7, it says write an equation in function notation for the situation. So it tells us airport parking is available for $8 per day. Okay, so to do this, I want you to go back to our 3-box strategy. So we did this a while ago, our 3-box strategy. So my first question is there an upfront amount in this problem? Is there an upfront amount? So airport parking is available for $8 per day. Does it say like you have to pay like $50 before you can park there? No, there's no upfront amount, right? So the upfront amount would be none. There is none. And then what's your rate? Well, your rate is the $8 per day. Your rate, $8 per day, and we don't know the total. So now I'm going to take none. So how do I show none in math? That's just a 0, right? So 0 plus 8x is equal to y. However, this is not function notation, and they want function notation. They want it in the fancy way. So all I've got to do is I'm going to take this. I'm just going to move that over, and I'm going to, instead of a y, I'm going to use my fancy function notation, and then is equal to 8x. So I just swap spots, and I don't need to put the 0 on the end. So there's your function notation. F of x is equal to 8x, $8 per day. All right. Number 8, write an equation in function notation, same thing, for the situation. A glass of iced tea costs $2, refills cost 25 cents. Okay, so think about this. We've got 2 different costs. We've got the glass of iced tea, and then we've got the refills. So think about which one would you have to pay up front and which one is a reoccurring cost. Okay, so think about that. So which one would we pay up front and which one's a reoccurring cost? So get this out of here. All right, so the upfront would be the $2, right? The $2. And then the refills would be 25 cents per refill. And then we don't know the total. Okay, so now I'm going to write an equation in function notation. So I'm going to go $2 plus 25 cents per X. That's going to be my number of refills equals Y. And now if I want it in function notation, I am going to just rearrange things. Instead of a y, I'm going to do f of x, and then here's my rate, and then I put that up front at the end, at the back. Okay, so kind of like number 7. However, in number 7, there was no upfront amount. It was just 0. So on this one, we do have an upfront amount right there. Okay. All right, number 9. Find the slope of the line that contains these 2 points. So we've got this point, 4, 5, and 7, 11. Now, you could draw this on a graph, but I think it would be just as fast, if not faster, to use the formula. So what I'm going to do is I'm going to list those out. In fact, I'm going to label this. I'm going to call this point number 1. I'm going to call this point number 2. And now the first thing that I taught you to do was to do the stack strategy. So I'm going to take point number 1 and I'm going to stack it underneath so that I have these lined up and I have these lined up. And now that I've got that stacked, now I'm going to write out my formula. So my formula is m equals y2 minus y1 over x2 minus x1. And now my y values are 11 minus 5. And my x values are 7 minus 4. So it's going to look like this right there. So 11 minus 5 is 6. 7 minus 4 is 3. Now I need to simplify this. So 6 over 3, I'm going to take that. I'm going to bring it over to there, 6 minus 3. And I know that 6 divided by 3 is 2. But since this is a slope, I want to make sure I've got a rise over run. So 2, I'm going to change to 2 over 1. And there's my slope, 2 over 1. Okay? 2 over 1. All right, number 10. Moving along here. Number 10, it's asking for us to find the slope of the given line. So of the line given by, here's our equation. Okay, now we know that the slope is always the value next to x. However, we don't have this in the correct format. This is in what we call standard format, and we need to change it to slope intercept. Okay, so we need to isolate the y. We need to get the y by itself, isolate the y. So if you think of like the backyard that we've talked about in the past, right? Here's the fence. This is the fence in your backyard. These guys are at the party here, 4x plus y, they're at the party. 8's not at the party. He's like looking over, he's like, oh, it's a cool party over there. So this is the party, but now we need y by himself. So we need 4x to leave the party. So we're going to subtract 4x, get 4x out of there. And now we have y by itself. We've isolated y. Here's the y, it's by himself. And this is a minus 4x now plus 8. And now we can identify the slope. The slope is the number next to x when y is by itself. And our slope is -4 over 1 because we want to make sure we have a rise and a run. Rise and a run. So your slope is -4 over 1. Okay. All right, let's move on to number 11. That's not number 11, up here. Okay, number 11 is the same type of problem. Find the slope of the line given by, so we have another equation, and this, we need to get y by itself. We need to isolate the variable. Isolate the variable. Okay, so right now y is not by itself. So y is hanging out at the party, and it's a party with y is hanging out with 3, and it's also hanging out with negative 15, right? So we're going to need to get rid of negative 15. So negative 15 is going to leave the party first. We don't want to mess with negative 5x because they're not even at the party, right? Here's the fence, right? They didn't get invited. The party's happening over here. We want negative 15 to leave the party. Okay, so these cancel. That's gone. Okay, and so now we get to here. 3y is equal to negative 5x plus 15. Now remember, this is like a dating couple, but we need y to be alone. So y is going to have to break up with the 3. So he's like, it's not you, it's me, right? So he's breaking up. So we need to get 3 out of there. So we're going to divide everything by 3. So those cancel right there. And we get y is equal to, and this is going to be negative 5 over 3. Those don't, remember, if it doesn't want to divide nicely, we just leave it alone. And then here, 15, 3 goes into 15 nicely, so that changes to a 5. And now we have our slope right here. Our slope, remember that's what we're trying to find, is our slope. And our slope is negative 5 over 3. This is our rise over our run. Negative 5 over 3, rise over run. Okay. All right, number 12. So they give us a function, f of x is equal to 6x minus 1, and they want us to find f of x when x is equal to 0 and also when x is equal to 4. Okay, so remember, this f of x, this is fancy way for writing y, the variable y. Okay? So what we want to do is we want to substitute. So here is our function. F of x is equal to 6x minus 1. So whatever number I put inside that parentheses, I want to drop it like it's hot, right? Drop it like it's hot right into there. We want to substitute. Okay, so it tells us to find x is equal to 0 and also x is equal to 4. So if I'm finding x is equal to 0, I'm going to put a 0 here. X is equal to 0. Okay, so I'm going to go drop x into 0 into there. So 6 times 0 is 0 minus 1. And so that's going to be a negative 1, right? 0, this is 0 minus 1 makes negative 1. So I know the dance partner, 0, is dancing with negative 1. Now I'm going to go do the same thing for the number 4. X is equal to 4. So I'm going to go and put a 4 here. I'm going to put a 4 here. I'm going to go drop that in. That makes 24 minus 1 is 23. So my pair over here is 4 comma 23. 4 comma 23. If I plug in a 4, I get out a 23. If my input's a 4, I get out 23. Okay. All right. The next one, I didn't make room for both because there was quite a bit. So on number 13, it says use a calculations chart to graph the function. Okay. Now, they don't tell us what the domain is, but they do give us a graph to look at. And if you notice on the graph, we'll get to the line in a second, but we have some negative numbers, we have some positives, up here's some positives, and down here's some negatives. So when we plug in some values into our calculations chart, I've told you that when they don't give you numbers, then pick these 5. Negative 2, negative 1, 0, 1, and 2. So we want to pick those 5. And then here's my function. Here's the body of my function, negative x plus 3. I'm going to plug in these one at a time, and I'm going to get an output. So if I plug in negative 2, a negative and a negative is a positive. So positive 2 plus 3 makes 5. If I plug in a negative 1, a negative and a negative is a positive 1. So positive 1 plus 3 is 4. If I plug in a 0, well, that's 0. 0 plus 3 is 3. If I plug in a 1, now this becomes a -1. So 3 minus 1 is 2. And if I plug in a 2, I get 3 minus 2, and that's going to equal +1. So my dance pairs are -2's dancing with 5, -1's dancing with 4, 0 with 3, 1 with 2, and 2 with 1. So now when I come over here, I can draw my graph. So we said -2 and 5. So I'm going to go -2. Remember, these are they lead when you're dancing and graphing. So I'm going to go -2 and then up 5. And then the next one is -1, 4. So I'm going to go -1 and then go up and find my dance partner. And then 0, 3. And then 1, 2. And 2, 1. So I've got point, 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 point. And since they tell us it's a function, we know it's a function, we can go ahead and just put a ruler up there. Put a ruler up there, draw your line, and we can throw some arrows on the end of it because we know functions will go on forever. Now, the other thing that I want to point out to you is this is a negative slope, right? If I was to put a bowling ball up here and let it roll downhill, it would roll downhill. It's a negative slope. Well, look right there. Your slope right over here has that negative. So it is a negative slope. Okay. All right. 5 more problems. Here we go. Okay. Number 14, we want to find the slope of the points. So there happens to be 3. That's a pair, that's a pair, and that's a pair. So we only need 2 of them. So I'm going to take that pair and I'm going to take that pair. So when I come over here, I'm going to use my formula. I'm going to write it out. Okay, so -3, -5, that's 1 point. And 0, -9 is another point. I'm going to do the stack strategy. So I'm going to take this, I'm going to move it over and stack it. So now I've got these stacked up, got these stacked up. And I'm going to use my formula, my y2 minus y1. So I'm going to go -5 minus, I'm sorry, -9 minus -5. -9 minus -5. And so that's going to change, those change to positive. Remember scoreboard, that changes to positive. So -9 plus 5. So the negatives win by 4. So -4. And then I'm going to do 0 minus -3. 0 minus -3. And those change to positive. So 0 plus 3 makes 3. So this is my rise. That's my run. And if I come over here, there's my answer. I can't do anything else. I can't simplify. So the slope, M, is -4/3. That's my rise over my run. All right, number 15. Says a jogger runs 4 miles per hour. The function f of x equals 4x gives the distance the jogger travels in x hours. Graph the function. And then down here it says, how many miles will a jogger run if he runs for 90 minutes? Use the function to answer the question. Okay, so the first thing that I need to do is I need to think, well, is there a starting amount? Does it say that the jogger has already jogged 30 miles this week? No, it doesn't say anything about that, but it does tell us what his rate is. So there is no upfront starting amount, but we do know his rate, 4 miles per hour. Okay, so if there's no starting amount, then I'm going to start at 0. And if the rate is 4 miles per hour, that's my slope, right? My slope, if that's my rate, then I know my slope is equal to 4 over 1. 4, whoops, you can't see it. 4 miles for every 1 hour. So now when I graph this, I'm just going to go up 4 and over 1 hour, right? So if I was to plug in a 1, I plug in a 1, he's going to travel 4 miles. Then I can go up 4 and over 1, up 4 over 1, up 4 over 1. And now it doesn't tell us that it doesn't say time stops, right? So since time doesn't stop, then I'm going to draw a solid line. I don't want just a point and then another point and then another point and another one, right? He keeps running. Time doesn't stop, right? Once you're here, once you get to 1 hour, it doesn't all of a sudden just like stop, right? It keeps going. Okay, so now let's go and figure out how far he would run if he runs for 90 minutes. Okay, so there's our rate, right? They already gave this to us, right? F of x is equal to 4x. Hours is our input. So we want to plug in the number of hours. Well, they didn't really tell us the number of hours. They told us the number of minutes. And the number of minutes is 90 minutes, and 90 minutes is equal to 1.5 hours, right? 90 minutes is 1.5 hours. So I'm going to go over here, and I don't want to plug in a 90. It's not 90 hours, it's 90 minutes. So I'm going to plug in 1.5. So 4 times 1.5 is 6. And so my final answer, since this is a word problem, the jogger will run 6 miles in 90 minutes. The jogger will run 6 miles in 90 minutes. Now, does this make sense? Let's go back and look at our graph. Well, we said that in 1 hour, he would run 4. In 2 hours, he'd run 8. Well, what about an hour and a half? If I go up, looks like right there is probably 6. So it does make sense. So we know that the jogger will run 6 miles in 90 minutes. All right, last 3 problems. Okay, so on this one, it says use the graph to identify the outputs for each input. Okay, so these are the x values, right? These are the x. So this is like f of x. So if I put a 1 in, then I want to find out what my output is. If I put a 2 in, I want to find my output. If I put a 3 in, what's my output? And a 6 in, what's my output? So remember, these are the x values, right? The x values. So I'll give you the answers, and then I'll have you copy down how I did it. Okay, so the answers are -1, and then 1, and then 3, and then does not exist. Okay, now think about this. I just redrew it. I forgot to copy it over here. Okay, so if x, remember this is f of x, this is f of x. Okay, if x, that's x, so if x is 1, so I'm going to go look on my x-axis, I'm going to go look at my x-axis, and I'm going to go over to 1. Well, where's the graph at 1? It's down here at -1, right? This would be -1. So that's why I put a -1. And then if I go look at my graph on when x is 2, if I go over 1, 2, well, where is the graph? At 2, it's up there. All right. It also happens to be down there. Look at that. It's in 2 spots. Okay. So that is up there, and it's also down there. Okay. So I need to add a number. So this is at 1, and this is also at -1. At -1. In fact, let me change that. So This is at +1 and -1. Okay. All right. That's an and. Okay. All right. So it's at +1 and -1. If I go to the next one, if X is at 3, I'm going to go over here and I'm going to go up to there. That's at 1, 2, 3. And I'm going to go down and it's also at -1. So it's there and it's there. So it's at 3 and -1. Okay. But then on 6, if I go 1, 2, 3, 4, 5, 6, well, the graph doesn't hit 6, right? It stops at 5. So this we'd say does not exist or undefined. Okay. All right. So that hits in 2 places. This one hits in 2 places, right? It hits there, and this one hits right here and up there. Okay. All right. Number 17. Find the slope of the line. So all I'm going to do on this one is I want to just go find spots where the graph hits the grid, right? Where it hits the grid, where it hits a crossing. So I came over here and it seems to cross right there. It seems to hit a grid like this one right here. This right there doesn't hit at a grid mark, right? So it hits the grid there. It seems to hit the grid right there. And it seems to hit the grid up there. So now I've got these points and then I'm just going to see what that slope looks like. So if I'm here, I'm going to go up 1, 2, 3 over 1. Let's see if that works again. Up 1, 2, 3 over 1. Get in your elevator, go up 1, 2, 3, get out and run 1. So there it is. That's my rise over my run, 3 over 1. So I have a slope of 3 over 1. All right, so one more time, I just found points where it hit the grid, like this one right here, doesn't hit the grid. It doesn't hit it at an intersection. I'm only finding places that hit an intersection. Okay. All right. And then question 18, it says determine the domain and range for number 17. So I'm looking at this and we've already covered this extensively, but since that's an arrow and that's an arrow, that means my graph is going to go forever. It's going to go forever going up and also forever going that way, right? It's slowly working its way up and it's also slowly working its way that way. And over here, it's slowly working its way down and it's slowly working its way that way. So for my domain is your X values. So if I know that it's slowly going that way and it's also slowly going that way, right? Or remember we've talked about, if you think of like the magnet, right? If there's my line and I turn on the X-axis, it's going to spin it. And since it's got arrows, it's going to go to infinity, right? To infinity, negative infinity, and positive infinity, because it's going to go that way forever. It's also going to go that way forever. Then the other way to say that is all real numbers, okay? And then for your range, it's going to go to positive infinity and negative infinity, right? It's always going to be traveling up. It's always going to go up. It's never going to stop because it has arrows. And it's always going to be traveling down because it's got arrows. It's never going to stop. So we would say it's going to go from negative infinity to positive infinity. We use parentheses because we can't touch infinity. We're not able to touch infinity. And then we could also say all real numbers. If you don't want to draw the infinity signs, you could just say all real numbers. Okay, all right, so that was a lot, and hopefully that makes sense. Feel free to stop the video, feel free to go back, pause, but hopefully you're listening to the video. Hopefully you're not just writing stuff down without listening to me, because I think I do a pretty good job of explaining. Okay, all right, that's all I've got for you, and I will see you guys. Bye.